Hello friends, good morning to all of you. I am Dr. Raju and welcome to this channel, welcome to this online classes. So in this session we are going to talk about oxidation number part 2. In part 1 we have discussed the basic definition of oxidation number and the set of rule we are using to calculate the oxidation number of atoms in a different molecule. So I think you must have remembered the uh, definition of oxidation number. So what is the definition of oxidation number? See here, I am writing the definition here. Uh, oxidation number is the number of charge uh, the atom would have would have the atom would have in a molecule or ionic compound if electrons were transferred completely. This is the definition of oxidation number. So it is the number of charge. The atom would have in a molecule or in any compound if electrons were transferred completely. If the sharing of electrons between two atoms occurs, and we have to suppose one atom is going to transfer its electron to another atom, and using the set of rule we can find the oxidation number of atoms in a molecule. So we are I'm giving you 5 different compounds where you have to find oxidation number. So we have S2SO4, S2SO3, H2S, S2SO5, S2O8. See here, we have to find the oxidation number of sulfur in each compound. So we know the rule for assigning the oxidation number. You know the sum of oxidation number of each atoms in a molecule. The algebraic sum of oxidation number of each atoms in a molecule will be 0 if the molecule is neutral. So in H2SO4 we have to assign the oxidation number of sulfur. So we know that oxidation number of hydrogen is +1 multiplied by 2, and we have to suppose the oxidation number of sulfur is X. So plus X plus oxidation number of oxygen is -2 multiplied by 4 equals 0. After solving, we get x is equal to +6. So the oxidation number of sulfur is +6 in case of H2SO4. What about in H2SO3? In H2SO3, let the oxidation number of sulfur be x. So for H we have +1 multiplied by 2 plus x plus 2, -2 plus 4 equals 0. So 2 1 is 2 plus x plus minus 4 2 is we have H2SO3. We already have H2SO4. So this is not 4, this is 3. So 3 2 is 6. After solving it, we have x equals +4. So in sulfurous acid, the oxidation number of sulfur is +4. In sulfuric acid, the oxidation number of sulfur is +6. In H2S, in case of H2S, suppose the oxidation number of S is x. So 1 multiplied by 2 plus x is equal to 0. So x equals -2. So in case of hydrogen sulfide, the oxidation number of sulfur is -2, and -2 is the minimum oxidation number of sulfur. You must remember the oxidation number of sulfur varies from -2 to +6. +6 is the maximum that we have in case of sulfuric acid, and -2 in case of H2S, and -2 is the minimum oxidation number, and +6 is the maximum oxidation number. So you must remember the maximum oxidation number is equal to the number of valence electron present in an atom. Maximum oxidation number equals number of valence electron. So if you know the number of valence electron, we can say about oxidation number. The maximum oxidation number is equal to the total number of valence electron, and we can find minimum oxidation number if you know the number of valence electron. So it is number of valence electron -8. So in case of sulfur, the atomic number of sulfur is 16. So we have its electronic configuration like 1s2, 2s2, 2p6, 3s2, and 3p4. So 2 plus 2 plus 6 plus 2 plus 4, we have total 16 electron in sulfur. So the outermost shell is 3, and it has 6 electron. 2 plus 4. 2 plus 4, that is 6. So the valence electron of sulfur is 6. So the maximum oxidation number of sulfur will be +6 and minimum will be -2. Similarly, in case of nitrogen, we have minimum oxidation number of -3 and maximum of +5. And we have different molecules which have different oxidation number, and that must be in between -3 and +5, because this is minimum oxidation number and +5 is the maximum oxidation number in case of nitrogen. Now, what is the oxidation number of sulfur in H2SO5? H2SO5 and H2S2O8. H2SO5. Let the oxidation number of sulfur be X. So 1 + 1 + 1 multiplied by 2 plus, for sulfur we have X. For oxygen, -2 multiplied by 5 equals 0. So +2 plus X minus 5 to the 10 equals 0. So X equals +8. So after calculating whatever I read till now, we get in case of H2SO5 the oxidation number of sulfur is +8, which is not correct, because you know the maximum oxidation number of sulfur is +6. It can never be +7, +8, +9. So it must be +6 or less than +6, but not more than +6. So what has happened in the case of H2SO5? H2SO5 is also known as carroage acid. You must remember its commercial name or common name, carroage acid. H2SO5 is called carroage acid. So in H2SO5 we get the oxidation number of sulfur is +8, which is not correct. It means all the oxygen present in H2SO5 is not going to have -2 oxidation state. Is not going to have -2 oxidation number. There must be presence of peroxide bond, that is covalent bond between two oxygen atoms. So we have to know the number of peroxide bond in the given compound. So we have a ready-made formula for that. By using the formula, you can calculate the number of peroxide bond. So the formula is number of peroxide bond equals, first we have to know the number of oxygen atom present in a molecule. So in case we have 5, so number of oxygen atom, and we know each oxygen atom tries to have 8 electron in its outermost shell because of octet rule. So multiplied by 8, and 8 represents the number of electron minus total valence electron, total valence electron divided by 2. And total includes each and every atom present in the molecule. So using this formula, calculate the number of peroxide bond in H2SO5. So we have 5 oxygen atom, 5 multiplied by 8 minus total number of valence electron, So for hydrogen, each hydrogen has 1 electron, so 2 hydrogen atom will have 2 plus. For sulfur, the outermost shell of sulfur has 6 electron plus 6, and oxygen also have 6 electron multiplied by 5, because we have 5 oxygen, and divided by 2. 5 8s are 40 minus 8 plus 6 5s are 30 divided by 2. So 40 minus 38 divided by 2, and we have 2 by 2, that is 1. So the number of peroxide bond present in H2SO5 is 1. That is 2 atom in case of H2SO5 shares their electron and forms peroxide bond between them. So the structure would be sulfur, oxygen, and we have 1 peroxide bond, and we have hydrogen, and this is the structure of carriage acid or H2SO5. So it has mono peroxide bond, 1 peroxide bond in H2SO5. So it is also known as peroxy or peroxo monosulfuric acid. Carriage acid is also known as peroxo monosulfuric acid. We have 1 peroxide bond, and one sulfuric acid, H2SO4. So in case of carriage acid or H2SO5, 2 oxygen atom will have oxidation number of -1, because peroxide has -1 oxidation number, oxidation state. So now we can calculate using the concept we have learned. So for hydrogen, +1 multiplied by 2 plus X, let the oxidation number of sulfur be X, plus out of 5 2 will have -1 and 3 will have -2. So -2 multiplied by 3 plus -1 multiplied by 2 equals 0. So 2 plus X minus 3 to the 6 minus minus 2 equals 0. So we have X equals +6. So in case of H2SO5, we have +6 oxidation number of sulfur as well, because because oxidation number of sulfur can never be more than +6. +6 is the maximum oxidation number of sulfur in case of H2SO5. Now, what about H2S2O8? H2S2O8. H2S2O8. If we calculate using the general concept, we have +1 multiplied by 2 plus X multiplied by 2 because we have two sulfur atom, plus -2 for each oxygen atom multiplied by 8 equals 0. 2 plus 2x minus 8 to the 16 equals 0. So 2x equals 14 and x will be +7, which is not correct. This can never be the oxidation number of sulfur because the maximum oxidation number of sulfur is +6, that we know. So what happens in case of H2S2O8? In H2S2O8, it is also known as Marshall's acid. Marshall's acid. Remember its commercial name or common name, Marshall acid. H2S2O8. So using this calculation we have +7, which is not correct. So the things that happens in the case of H2S2O8, it must have peroxide bond, peroxide linkage. So first we have to calculate the number of peroxide bond in H2S2O8. How can we calculate number of peroxide bond? So the number of total oxygen atom we have 8 multiplied by 8 because of octet rule minus total valence electron we have to calculate, we have to know. So for H2, because we have 2 hydrogen atom, for sulfur we have 12 because each sulfur atom contains 6 valence electron, plus we have 6 into 8 divided by 2. So 8 is 64 minus 14 plus 6 is 48 divided by 2. 64 minus, after adding we get 4 plus 8 2, 4 plus 1 5, 5 plus 1 6. So 2 by 2 we have +1. So the number of oxidation number will be the number of peroxide bond in case of H2S2O8 will be 1. H2S2O8 also has 1 peroxide bond. So using the concept of peroxide bond, we can calculate the oxidation number of sulfur in H2S2O8, that is Marshall acid. one peroxide bond indicates that two atom, because peroxide bond is formed between two oxygen atom. So two oxygen atom will have minus one oxidation number. So for H, plus 1 multiplied by 2 plus X multiplied by 2 plus, out of 8 we have 6 oxygen atom which will have minus 2 oxidation number. So minus 2 multiplied by 6 plus minus 1 multiplied by 2 equals 0. Minus 1 multiplied by 2 equals 0. So 2 plus 2x, 6 2 ja 12, plus minus minus 2 1 ja 2 equals 0. Sorry. We have 8 oxygen atom. So minus 2 multiplied by 6, and now after solving we have 2x minus 12 equals 0. So x plus 6.